Hey guys, in this video we're going to be talking about solving and graphing inequalities. So inequalities are very similar to equations, except instead of having equal signs, they will have an inequality sign because there's a range of answers that would make the situation true. So let's start with a one-step. Alicia has read approximately 1/4 of a novel. If she has read at least 112 pages, how many pages are there in the novel? All right, so the first thing we need to do is define our variable. That's done the exact same way we did for equations. So what is it that we're trying to find? So it's how many pages are in the novel. So we're gonna say X is number of pages. All right, part B, write an inequality that represents this situation. So let's underline the important information. So we know that has read about 1/4 of a novel, and she's read at least 112 pages. So 1/4 is 1/4, and of means multiplication. So 1/4 of the novel. Now remember, if X is number of pages, that's the number of pages the novel has. So it's 1/4 of the number of pages, and it's at least 112. So that tells me that 112 is my total. So that's going to be on the other side of my inequality sign. Now what I need to do is figure out which way the sign should go. Now I know that the left side here represents the actual number of pages of the novel. The words at least means 112 or more. So this side over here has to be at least 112, can be bigger. So I'm going to put greater than or equal to, because I know that it can be 112. And then part C says solve your inequality and think about if your answer is reasonable. So if I know that my book has to be at least 112 pages, my answer had better be 112 or more when I solve it. So that's what I'm thinking about when deciding if my answer is reasonable. To solve this problem, I can do one of two things. I can divide by 1/4 or multiply by its reciprocal, which is 4. I'll go ahead and divide by 1/4 on both sides. And I am dividing by a positive number, so I do not need to worry about switching the sign. So what I'm going to do is take out my calculator and do 112 divided by 1/4, and I get 448. So I'm going to keep the sign the same, and I get 448 pages, which is greater than 112, so I think that this answer is reasonable. All right, that was part C. Part D says graph your solution on the number line, or on a number line. So that's also very similar to when we were graphing solutions to equations, except for the actual act of graphing. So I know that 448 needs to be on here, and then I need two numbers on either side. I'll do 449 on the right and 447 on the left. Now, this symbol is going to help me decide not only where the dot goes, but we also have to think about what other numbers of pages satisfy this inequality. So first of all, this equal to underneath tells me that I can close the circle on 448. So that's the first change from graphing an equation. Equations are always closed, inequalities are not. This one has an equal to underneath, so it's closed just like an equation. And then I have to decide, do I need all of the numbers greater than 448 or all of the numbers less than 448? So my symbol says greater than, so I'm going to use all of these pages this way. Another trick that you could use is looking at the symbol itself. If your X is on the left-hand side, your symbol will point to which way you need to graph. But that only works if X is on the left, so be very careful with that. Now part E wants to know what are two possible solutions. So for part E, I want to choose the number of pages that make this inequality true. Well, I could choose 448. That one's an easy one because the circle is closed. So 448 pages is one option. Another option would be 449 because it's greater than. So 449 pages. These are two solutions that make the inequality true. All right, let's try another. Moving on to two-step inequalities. It says, Jamal has $40 to buy tickets to a performance for himself and his friends. If he buys a $10 membership, he can buy tickets for $5 each. How many tickets can he buy while remaining within his budget? All right, so same beginning steps. Let's define our variable first. So it's going to be X is, and we are looking for how many tickets. So number of tickets. Part B is to write an inequality that represents this situation. So this one's going to be more similar to a two-step equation, except instead of the equal sign, you have an inequality sign. So let's find the important information. We know that Jamal has $40. That's his total, right? He can't go over that amount. If he buys a $10 membership, he can get tickets for $5 each. All right, so let's start with that. Tickets are $5 each, and I know that X is number of tickets, so that's going to be 5X. But you have to remember that in order to get the $5 tickets, he has to purchase a $10 membership. So we're going to tack that on to how much he pays. We also know that he has $40. That's the total amount that he has. So that's going to go by itself on the right-hand side. Now we have to decide on which way the sign goes. Now, this left side here represents how much money he spends. We know that he only has 40. So this side over here cannot go past $40. So it has to be less than. However, he could also spend all 40, so I'm going to put the or equal to underneath. So that's part B. Part C says to solve our inequality. So the first thing I'm going to do is subtract 10. And I get 5X is less than or equal to 40 minus 10 is 30. Divide by 5. I get X. I divide it by a positive, so the sign stays the same. 30 divided by 5 is 6 tickets. This means that he can buy 6 or less tickets, or you could say he can buy up to 6 tickets. All right, part D is to graph. So we're going to draw our line. We'll do 5, 6, and 7. There is an or equal to underneath, so I'm going to close the circle on 6. Okay, and it says he can buy, so X, the number of tickets he buys, is less than or equal to 6. So this time we're going to go this way. And then two solutions. So in other words, what are two possible numbers of tickets that he can buy? Well, he can buy 6 tickets. He could also buy 5 tickets. Anything less than 6 will work. All right, let's try another two-step. All right, Jay wants to rent a metal detector to use at the beach. A rental company charges a one-time rental fee of $15 plus $2 per hour to rent a metal detector. If Jay only has $35 to spend, for what number of hours can he rent the detector? All right, same steps. Part A, define your variable. We want to know for what number of hours. So X is number of hours. Part B says write an inequality that represents the situation. So let's find the important information. All right, so there's a one-time fee of $15 and it costs $2 per hour, and Jay only has $35. Okay, so it's $2 per, there's that word per we always look for, per hour, and X is hours, so that's 2X, plus the one-time fee, which is $15, and the total that Jay has is 35. So now we need to decide on the sign. This left side here represents what Jay pays, and he only has 35, so it cannot exceed $35. So it's got to be less than, but it could be equal to. So that is the inequality that represents the situation. So let's solve. Start by subtracting 15. That's going to give me 2X is less than or equal to 20. Divide by 2. Once again, I'm dividing by a positive, so I'm going to keep it. X is less than or equal to, and 20 divided by 2 is 10 hours. That's part C. Part D is to graph. We'll do 9, 10, and 11. There is an or equal to underneath, so we're going to keep that. And it's got to be less than 10. Or equal to. So we're going to go this way. So that's the graph. And then finally, two solutions that work. In other words, what are two number of hours that Jay could rent the metal detector for? Well, we know that he could do 10 hours because that circle is closed. So I'm going to say 10 hours. And then anything less than 10 will work. So let's choose, I don't know, 6 hours. That works because it's less than 10. Let's try one more. This time we're going to have variables on both sides of our inequality. Okay. Admission to the zoo is $59.50 per visit. However, if you purchase a season pass for $60, admission is only $39.50 per visit. To make the season pass worth it, at least how many times would you need to visit the zoo? All right, so part A is define your variable. So we're looking for how many times or how many visits. So X is number of visits. Okay, now remember when we talked about equations with variables on both sides, we were comparing two things, which is exactly what we're doing here. We are comparing the price without the season pass to the price with the season pass and trying to decide when it is beneficial to have that season pass. So essentially what I'm looking for is when is the season pass going to be cheaper than using the non-season pass. All right, so let's write an inequality that works for both here. So season pass. I know that the season pass is $60 and that admission is $39.50 per visit. So that means I'd have to pay the $60 and then each time I visit, I pay $39.50. So that would be 39.5x, okay? And then without the season pass, it's just straight up $59.50 per visit. So that's 59.50x. Now remember, we want to know how many times you'd have to visit the zoo for the season pass to be worth it. So in other words, when is it cheaper to have the season pass? That's why I chose less than. I want this amount over here to be cheaper than this amount over here. And cheaper means less than. Now I don't want it to be equal to, because then I'm still spending the extra 60 that I don't need to here, okay? So I want to know when is it cheaper. So that is the answer. That's my inequality. Now let's go ahead and solve. Now remember, when you have variables on both sides, the goal is to get them together. So I need to move the x's to the same side. Now this side, all they have is a variable term. So I'm going to take this variable and move it over this way. So minus 39.5x on both sides. Okay, so now I have 60 over here is less than, and then 59.50 minus 39.50 is 20x, and then I'm going to divide by 20 on both sides, and 60 divided by 20 is 30. This I divided by a positive, so the sign stays the same, and then I'm going to put my x down here. All right, now if you don't like having the x on the right, it is okay to flip it around, but you have to remember that you flip the sign as well. So there's another way I can write this. If I want the x over here and my 30 over here, that's fine, but make sure that the sign is still pointing the same way. So if it's open towards the x here, it needs to be open towards the x here. And then it's 30 visits. So you would have to go to the zoo 30 times for that season pass to be worth it. That seems like a lot of visits to me. All right, so that was part C. Part D is going to be our graph. We'll do 29, 30, and 31. This time there's no or equal to underneath that symbol. So that's got to be an open circle, not closed. And then again, it's 30 visits or more because x is bigger than 30. So my line is going to go over to the right this way. And then finally, we want to know part E, what are two possible solutions? So what are two possible numbers of visits that would make this inequality true? Now remember, this time 30 is not filled in. That means 30 visits won't do it. You have to go at least 31 visits. So we're going to do 31 visits. And we'll pick another number that's greater than that. I don't know, let's do 40 visits. both of those would make the inequality true. So the one thing I want to touch on that's not in here is that you need to remember if you are dividing by a negative number, or if you're multiplying by a negative number, you have to flip this sign. But these are all real world problems, so that doesn't happen very often in real world situations unless you are solving a specific way. But do be careful when you are working with inequalities. But that's it. That's how you solve and graph inequalities.